A is a bit of a poorly worded question. It's a little bit of a poorly worded question because is pi over 4 on your pi plate? Yes. So if you got this question, this is what I would want you to do. I would want you to be like, yes, I know that pi over 4 is on my pi plate. It's root 2 over 2. If I squared it, and then subtracted sine of pi over 4, which is root 2 over 2, and squared that, I think you could do this mental math pretty quick. This is equal to 0. This wasn't the intent of the author of this question. They didn't want you to do that. They probably wanted you to do something more in the lines of this, but I'm going to just do it as like another example. I'm going to do something very similar. Cos squared pi over 8 minus sine squared pi over 8. Okay. Now I don't have it on my pi plate. Pi over 8 is not on your pi plate. And you see this question on a non-calculator part of your exam, and you're like, uh-oh, I don't think we can do this one, right? So you're like, right, not possible, and cross your fingers and move on. But this could be a problem. However, this is where all of our formulas will try to mostly memorize. And of course, for the AP class, if you're taking the AP class next year, you do have to have these all memorized. And the idea would be, I recognize this as one of my cos 2 alpha formulas. So if we look at our 3 cos 2 alpha formulas, the first one says cos 2 alpha is cos squared alpha minus sine squared alpha. So that means I can change this to cos of 2, and my alpha was pi over 8, which becomes cos of pi over 4, and the answer would be root 2 over 2 in the end. We could have done that with part A, but part A was already on our pi plate, so it was a bit of a poorly worded question. Same thing with part B. Although part B, so I'll rewrite part B. Here we have 2 tan pi over 6 over tan, do I get that right? Tan squared pi over 6 minus 1. So you have, again, pi over 6 is on your pi plate. So you could just go directly and start simplifying this. Tan of pi over 6 is root 3 over 3. You could plug it all in and simplify. Again, that wasn't the intent of the question. The intent of the question was to give you this formula and see if you could use it. And also the intent of the question was for you to notice that does it match up perfectly? No. Notice the bottom of what we have is tan squared pi over 6 minus 1. And the bottom of the formula is 1 minus. It's like the order is switched in what is subtracting. Okay? So I'm not going to, I know you could plug in pi over 3 and do the fraction work and get the answer. And I would probably recommend doing that. But I'm going to show you how you could use the formula in this one. And it might actually be easier with the formula. First of all, if you ever have things in the opposite order like this, you can always factor out a negative 1. So I'm going to rewrite everything. I'm going to factor out a negative 1. That would change my 1 to positive and my tan squared to negative. Now this part, without that -1, matches this part. So how do we deal with a -1? Well, something about fractions. If you have a fraction and there's a negative on the bottom, like -2/3, well, 2 over -3, I'll read it correctly. That's exactly the same as -2 over 3, right? Which is exactly the same as putting the negative in front and writing -2/3. If you have a negative in a fraction, you can have that negative in your numerator, your denominator, or out in front. So I'm just going to take this -1, I'm going to erase it here. And I'm just going to put that negative out in front. Because now, what's in the green box, I can use the formula for. I can write negative, and this will be 10 of 2 times pi over 6. Because that green box, with the formula, we could change it to the left-hand side, which just becomes -10 of pi over 3, which is -√3. And you would have got -√3 had you plugged it in. So usually on the exam, they don't write the questions with values that you already know. They'll do stuff like I did with the pi over 8. Something that you don't know. Or, I'll add a part C to this one. They'll do something like this. Evaluate, non-calculator part. They'll do something like this. And this is from a final exam. And on the final exam, this is a 2-mark question. Which seems kind of interesting because you might have had on the same final exam this question, evaluate sine of pi over 12, and it was a 3-mark question. Because we just did pi over 12 questions the other day. They're very typical. In fact, there was a string of, I'm going to say, 15 exams in a row that every exam had a pi over 12 question. It was like always, almost a guarantee. In the last 5 years, there's been a couple years that they haven't had it. But it was almost like, you know there's going to be a pi over 12 question on your provincial exam at the end of the year. And so students got really good at doing pi over 12 questions. They're usually 3 marks. Well, if sine of pi over 12 is a 3-mark question, and cos of pi over 12 is a 3-mark question, this normally would seem like this should be a 6-mark question. Maybe even more if you had to simplify it. But they'll like to do this. They like to play with your brain a little bit. Because when you see the pi over 12, your brain probably would first go to pi over 12 questions. Does that seem like a natural thing your brain would think? That you've learned a whole bunch of questions that are pi over 12 questions, you see a pi over 12 and would think, I should do a pi over 12 question. But this whole thing is a formula on the right-hand side of your double angle identities. 2 sine alpha cos alpha is your sine 2 alpha formula. So you can take this whole thing and change it to sine of 2 alpha, which changes this to sine of pi over 6, and you get a half way easier than doing 2 pi over 12 questions and multiplying them together. Do you ever use, on an exam, do you ever look at how much something is out of and sort of gauge what you should do for a question like that? I should mess you up. I should make a test where all the easy questions, like 5 marks. And then all the hard questions are out of 1 mark, and you'd be so confused because you'd be like, do I have to show more? You'd probably, some of you would come up to me and say, this is all I did, but it's worth 5 marks. Right? It's a good strategy, right? You look at how much the marks are, and it kind of gives you a hint how much work you should do. Okay, questions you can circle on this one. 4, 5, and 6.